So this was a pump room. We had the opportunity to help design, construct. Thankfully, over the years, this has came to a really well-deserving customer of ours. We've been doing business with them for several years, but Hubbard Swim School has been kind of an icon in the valley for a number of years. Really pays attention to his employees, the instructors that he has there, as well as his patrons. And he always goes above and beyond when it comes to his pump rooms. That was one thing I really enjoyed working with Bob, is he liked to get the quality products in, and he likes to do things the right way the first time. So none of his pump rooms are built in any 2-inch plumbing of any type, period. It's all commercial, high turnover rates, 1 hour, 2 hour turnover rates, and so forth. But so when we got to put this thing together, I actually had wrote an article about a year or so ago, and it was the essentials to designing a pump room. And we really were flattered that we had the opportunity to put everything that we wanted to into this pump room. And it really, honestly, this really couldn't have came to a better facility that it was for a swim school. That's one of the things that's closest to my heart, is the kids, and being able to supply or provide a very safe environment for them, and not to mention even the instructors in there, just because they suffer so much from water quality issues. But nonetheless, so kind of as I went through this pump room, we gotta do everything that we really wanted to in there, and I took in some of our favorite builders we like to use. We had Jeremy from the Premier Paradise help us on this. I had our designers from Aqua Design International. And then as far as the guys that came in and actually helped with the plumbing and so forth, was J-Max. Did a great job, threw in some really nice ideas in there. So we actually got to bounce things off of one another. I don't claim to be the best guy for hydraulics, very particular about it. J-Max does a great job of understanding that too. So now we'll take a look at the equipment room. So here we decided to go with 2 pumps instead of a single pump. Kind of gives you that redundancy on there. If you notice, you want to hold that for a second there. The header on these pumps, so the suction header there, that was actually specially designed to make sure that neither one of those pumps is going to struggle getting water. So the efficiency factor in there is really extremely good on there. So then that way, nice thing is, if we had a pump failure, at least we've got another pump on there. Those are 7.5 horsepower pumps. We still have way more turnover than an average pool, even with just 1 pump, which was really nice. But as you can see on there, the valving is very important on all these systems that we do. Everything is isolated across the board. So we're very particular on being able to run a pump room regardless of what the situation is, of some equipment going down and so forth. But go ahead, we can move from there. Coming out of the pumps, obviously very important to have your check valves coming on the output side, as well as isolation valves on the output. Both of these pumps go into, once again, a larger header for hydraulics, obviously, to keep that correct. And if you notice these filters, they're very large filters. These things do a tremendous job, and we love using these filters. The deep bed sand filters do such a phenomenal job of pulling out particulates from the water. We can kind of pause it there for just a second. Each one of these filters, if you notice, they have butterfly valves on each one. Every one of these actually can be isolated. So once again, If we ever had a problem with the filter, we can isolate that filter. We can work on it without affecting the swim school whatsoever. They can still run. We also have VFDs on there, so we can control the pump speeds and slow it down and still keep our filter media rate and so forth, which is truly essential for any swim school, because downtime is very frowned upon, per se. But on these filters, if you notice the size of these things, normally you see these little tiny filters, 7 square foot thing you'd see in a backyard pool. Completely different. We're running at 600 gallons a minute here. It's got an hour and a half turnover rate, which is very important for keeping that water super clean. These filters were also filled with glass media, very dense material. Therefore, we actually pull out a very, very fine particle. The rate at which the water is flowing through these things, it actually gave us a filter media rate of 10, which means it's super slow. Most facilities run at about a 15 or more. But because of the flow rate is the reason why you see these filters so big. And we can go ahead and play it from there. But each one of these filters, the nice part is, once again, the redundancy in there. We have a tremendous turnover rate in here, which is super important for keeping that water clean. We also have a manifold on the front there. That's actually a bleed manifold for the tops of the filters, so you don't have to climb on top to bleed them out after backwashing and so forth in there. But these filters, the way it was designed, can actually pull down to 3 microns. And the nice part is, because the water is going through there so slow, they'll last a long time. They won't have that stress factor on them, so the pressures and stuff are a lot less. We have a digital flow sensor, if you can see on there. That's on the water going up, so really the chance of that flow meter failing for getting stuff caught in it or pipe not being full is like nil. Great place to put the flow meter when you have the opportunity to do that. So I was glad that we had some room in this pump room. We don't always have that much space available. Then coming over, the next piece of equipment we come into is the UV system. Obviously, most facilities today really want to have some sort of a UV system on there. It does sterilizing. They like the fact that they have that cryptosporidium kill factor on there. So it's that extra peace of mind. Most people, even though despite they don't understand all the particulars about a UV system, it's very important to have that on a facility. So we made sure to have that on there. Now this particular setup, we'll come back to this UV here when we get through here, because this UV provides a whole nother level of understanding and disinfection than most systems provide. So, but UV on for the most part is part of sterilizing the water, doesn't provide anything for oxidation. Next piece of equipment in line there, the inlet and the outlet to, we want to pause it for just a second there, inlet and the outlet to the heater. Once again, it's really important to understand that 100% of this water is treated in all aspects. So once again, all the water after it's coming from the UV system, now it can go through the heater and so forth, still untreated at this point. And the sequencing on all of these pieces of equipment is very important when we put these together. Everything serves a purpose, and it's very meticulous, for say, when we put these together. So once again, we have to follow the Arizona Boiler Code or OSHA code on there. So ball valve on the inlet side, and then we have a check valve and then a flow meter on the output side, so we can dial the efficiency factor in there perfectly. We can move on, keep moving there. The next piece of equipment in line is the system we call Aqua Fusion, or I'm sorry, AquaGen Ultra. And the AquaGen Ultra is our newest piece of machinery. It's really, really cool to see what this does. But the AquaGen Ultra, it encompasses both oxygen and ozone ultrafine bubbles. So it basically diffuses both the oxygen and the ozone. So important thing on this is getting the sizing correct. So despite the fact this is a relatively small pool, 55,000 gallons, we actually put a 30 gram an hour unit on there. But as it runs through the Aqua Fusion or the AquaGen, it actually diffuses both the oxygen and the ozone into solution. And then we feed it into a set of contact tanks. And just off to the right here, you'll notice too, is we have our CO2 system. If we play that, we can probably get that next piece of equipment in there. So just right next to it, the AquaGen and the pure feed, and a pure feed is our CO2 mixer, they actually join together before they enter the main recirculation pipe again. And actually that's really important to understand as to why do we do that. Well, the ultrafine on the left side here, as we get to it, you'll see a set of contact tanks. So this is what really sets this system apart from 99% of the systems on the market, is bringing these two together. There's a purpose for that coming together there. So when we add ultrafine ozone, we actually are able to treat 100% of the water through special designed contact tanks. And we can actually see that process taking place as we get to it here. But they mix in there. So instead of just feeding like a 20% side stream and running through a couple contact tanks, we actually run 100% of the flow of the entire system, which is, in this case, 600 gallons a minute, through the ultrafine. So everything is not only gone through the UV system and had sterilizing there of any type of crypto or any microorganisms there, but with ozone is obviously, it's 20 to 3,000 times stronger than chlorine, and it's 10,000 times more effective at killing microorganisms. So the idea is to get as much of that water through the ultrafine as possible. Give it that contact time with the water. So as well as the contact area. So because the ultrafine are so small, the more area that we gave it, and as long as we were able to have all of the water touch those ultrafine, we get better disinfecting and oxidizing capabilities from it. So that's what we did. So we can move forward on the next portion here. So as it comes into the line, you can actually see it mixing in there. I know it's a little difficult to see that there, but it mixes in, it comes together with the CO2, and obviously the CO2 is only feeding as we need it for pH control. But the CO2, the pure feed, is 100% efficient when we have the right flow rate, which is about 85 gallons a minute running through there. And as we enter that, we diffuse that CO2 in there. When the pH control, I'm just going to say CO2 in this case, when it actually drops that pH, and that's what it's meant to do, it actually makes the ozone more efficient. And it does that by keeping it in solution for a longer period of time. So not only am I utilizing the CO2 through those contact tanks, but I'm also allowing the ozone to do a better job when it runs through those tanks as well. So if we move forward here, let's take a look at those contact tanks. So as it feeds in there, I get a little bit more time with the contact tanks with both products in there. The blue box you see on there is actually the oxygen concentrator to keep our ozone nice and fresh. So there's a contact tanks. These are specially designed tanks that allow, that are specifically designed for this pump room. The size of them and everything, will actually make them taller if need be. But these are 8 foot tall, and we've got several of those in there to hold in the ultrafine as long as we can, while still taking on 100% of the flow. So ultimately we want to have these in there. So one is to give that time. Two is to get rid of any of the larger bubbles that may occur inside these tanks, and then we actually let those off gas at the top of these tanks and so forth. So this is where all the magic takes place in here. Once again, we also have a bypass valve on these, this side of things. And it's just the tanks we have that. So if they needed to, for whatever reason, they can still run the CO2. It's still going to go back to the pool. We can isolate this if we ever had a leak or an issue with anything. We always keep that in mind. The serviceability is very important on there. But as we move forward here, so these ultrafine bubbles in this system, obviously they carry back to the pool, and they do a tremendous job of raising the ORP level in the water, which is one of the most important things to really understand is ORP, which is oxidation reduction potential. It increases the water's ability to oxidize and disinfect different contaminants as it enters the water. And with ozone in general, ozone does a fantastic job of raising that potential in the water. And that's why we choose it. It's just because it's so powerful. We run a lot of systems with no chlorine at all in backyard pools. And believe it or not, this is exactly the way we've designed them. And they do a fantastic job of treating that water. On the back side of the system, you can see back here we have a small set of filters, or the blue filters there in the picture. We can pause it there for just a second. But these we put in, this is on the fill line. We try to remove as many contaminants as we possibly can from the water. One thing is we deal a lot with a lot of naturopath doctors across the U.S. And one thing that we know for certain is any type of metals that you have in your water, it doesn't matter if it's in your home, if it's in your pool, they're very unhealthy for you. These filters do a phenomenal job of removing all sorts of metals from the water, copper, nickel, iron, etc. And we've used these on swim schools before, and they do a phenomenal job of removing those. So rather than having to, once again, treat the water with any type of chemicals, now we're removing it mechanically. So if you heard of probably a sequestering agent before. Sequestering agents, they actually dissolve the metals into solution. They keep them in solution. They do not remove them from the water, which I don't like. I want it actually out of the water. So rather than having to add another chemical to the water, well, now you're actually removing it. So your water actually stays much more fresh. It's actually safer that way, and you don't have to deal with another chemical that you're adding to the water on a regular basis. So that piece of equipment right there was very important to have on this particular system. And then we can kind of keep moving. And the other portion on there, they've been using a system called Myox system for quite some time. Bob has been very fond of that system because it's an on-site chlorine generator. And yes, it uses salt to create that sodium hypochlorite. But the beautiful part about this particular system is he's not using much of it. So it doesn't have to work very hard because all the heavy lifting has already been done. so he feeds very little chlorine. And as you can see here, he's got a holding tank there for it. They have a water softener as part of that system, and then they have the actual salt tank there. That's where they put all their salt in and so forth. And then obviously as it needs chlorine, it just produces it, puts it in this particular tank on the left, stores it in there. So when it calls for chlorine, that's actually liquid chlorine. So it just feeds in a small amount. And on this particular pool, all of his pools across the valley, we actually have them running relatively low chlorine. This is going to be the lowest chlorine residual he's going to have in any of his facilities. So we're going to keep this thing at about 1 part per million of chlorine, and that follows county guideline. Obviously, we still have to follow that county guideline in there, but nonetheless, his ORP will be much higher than that, and he won't have to really worry about running out of chlorine anytime soon. But this is actually the front side of the Myox system. That's what it looks like there. A lot of stuff going on. Has a Venturi type feed system for that, calling for chlorine. This particular piece of equipment, this is a prominent controller. Over the years, we actually were able to fully utilize these controllers to the full extent. So these controllers are now pretty much fully loaded. What I mean by that is we put on the flow meters on there, we put on pressure sensors on there, we put on level sensors on there. So tie them into the heaters to turn it on and off, tie it into the ozone units, tie it into the UV units, and then tie them into the VFDs. So anytime that they need to go on any one of their facilities, they can look at the entire pump room and they can actually shut it off from their house if they had to, if there was ever an issue. And obviously for swim schools, it's very important. Once again, it's about having very little to no downtime at all. So they get these reminders in there, hey, the heater's not working, prior to them coming in, so they can get it fixed before they actually open. So if things aren't functioning the way they should, we're able to get on it really quick and find out what's going on there. So the other thing is it's just backwashing, knowing where they're ready, what time it is to backwash when the filter pressures get high enough, if they've lost any product, the level sensors, flow sensors, if their flow is down for some reason. So really help them over the years to be super efficient. So now they're, rather than being reactive, they're more proactive at taking care of their pump rooms, which made a tremendous difference in their efficiency ratings and helping their guys to be trained, actually better trained. So we help them quite a bit in becoming more efficient in understanding what's happening in these pump rooms and little things to look for, so that they're not running into emergency situations all the time. On the left there, on that next to that controller, that is actually the CO2 controller. And once again, tied in, they have a large tank sitting outside the pump room. Tank location is very important, so you don't have any leaks. Nothing can, per se, get into the pump room. We can move forward a little bit there. You'll have to forgive the part-time plugins there. It's not typically what it looks like, so I was getting things up and running. So there's the CO2 controller. Very nice controller. Monitors the output feed rate on there. You have the ability, once again, to turn it on or off. On this controller, one of the other things that we do for these swim schools here is monitoring the alkalinity level. And the alkalinity on there, A lot of people had an issue in the past of their alkalinity rising relatively quick when they use CO2, which is understandable. CO2 actually adds carbon to the water, which raises your alkalinity. But because in the past the efficiency rating wasn't so good, you had very large bubbles going in there. It did not drop the pH quickly, so you ended up using more product. You had more contact time with the water to raise that alkalinity. So your alkalinity would go up relatively fast, and you'd use a lot of product to do so. So a lot of people did not like using that, which is totally understandable. So when we added our new product in here, the fact that it's 100% efficient, it completely diffuses all of the CO2 in there when you have the right flow rates on there. We used very little CO2, and it doesn't affect the alkalinity much at all. But nevertheless, it will still affect the alkalinity because you're still putting carbon in the water, just smaller amounts of it. So to manage the alkalinity, you use a very small amount of acid. So we tie it in once again to the controller. A couple different ways of doing that is, one is you could tie it into the to feed at the same time that the CO2 feeder is feeding, just a small amount of acid, so based on the type of pump you use. Or B is we put it on an events timer, and it feeds X amount of days a week for short periods of time, just enough to keep that alkalinity in check. And obviously over the weeks, you kind of just fine tune it in there to keep it in balance. But that helps keep it in check. And on outdoor pools, we'll do phosphate removers as well. Same type of setup, events timer and so forth. So they've been very, very helpful, this type of controller. Probably one of the best controllers I've had the opportunity of working with over the years, but does a great job. We also have on this controller is a Ppm probe. Very important that we use a Ppm probe for our systems, especially on the smaller pools. And the reason why is because the ORP goes so high, it's very difficult to manage that with an ORP probe. Just because of the swings on the ORP there. So without going too in depth on it, we use the Ppm probe, we manage that 1 part per million, and then I'm not too concerned whether my ORP is going to be 950 or 880. I don't have to worry about any type of swings, which keeps the water much safer, especially for the kids being in the pool and the instructors being in there 4 or 5 hours or more every day. So just a much safer environment for everybody.